Everybody, welcome back to another fun and exciting pre-algebra class. Today we will be in lesson 7.5. This is on page 318, page 318. All right, what we're going to be doing today is talking about something called direct variation. What direct variation is, you can take a look down here at the screen. I've got it in your book as well. Can look at both places. But direct variation is the relationship between two quantities where one is a constant multiple of the other. Now, that sounds like, whoa, what is that? That's deep. Okay, it's really not as deep as you think. So, what do I mean by that? Well, here's the idea. Let's consider, and we're going to look at this example all the way through today's lesson. Let's think of this as a factory that's producing automobiles, okay? So, for instance, if a factory produces 5 cars a day, okay, 5 cars every day, that is what's called the constant. That's a multiple, because every day they are going to produce 5 cars. What if it's 5 cars per hour? Okay, what if it's 5 cars per month? Whatever. The key is there is a set amount of vehicles that plant can produce in a day, in an hour, whatever it is. So now how do you find out? Let's say that it's per hour. And let's say that, so for every 1 hour that's worked, 5 cars are produced. So what if they work 2 hours? 2 times 5, there's 10 cars being produced. What if they work for 8 hours? 5 times 8, right? 8 hours times 5 cars is 40. 40 cars gets produced in that 8-hour span. Now, this is exactly what we're talking about here. So let's read that definition again. The relationship between two quantities. So the two quantities that we're talking about are how many hours are being worked and how many total vehicles are being produced. Those are the two quantities, okay? So if they work for 1 hour, if they work for 5 hours, if they work for 20 hours, whatever it is. Every single time that is being multiplied by, right here, it says by a constant, right? What is the constant? The constant is the number that never changes. In other words, that factory always makes 5 cars in an hour, no matter what. And I know that's not really reality, right? Maybe something breaks down or, something happens and they only make 4 in an hour, something like that. I know that's reality, but this is kind of like imperfect situation. That plant produces 5 cars per hour. So let's look at this right here. This is our formula, okay? Our formula is y equals kx. Now let's talk about what each one of those things actually are. So what is the y? This y right here, this is called the output. This is how many cars they produced in the 8 hours, for example, okay? They produced 40 cars in 8 hours. Why did they produce 40 cars in 8 hours? Because X is the input, that's the 8 hours, right? So there's the input, it would go right there. And then K, this K is what's called the constant. That's the 5, that's the thing that never changes. So if we plug that into this right here, we'd get Y equals, or the output equals, how many cars can they make equals 5, because that's how many they make every hour, times how many hours did they work. Let's say they worked 2 hours. Okay, so the y, the output, y equals, in this case, 10 cars. Okay, so our output right here, our y, is dependent. Look at this word right here. Dependent. It depends on what? Well, it depends on the independent variable, the x. It depends on this. And it also depends on the constant, right? So the answer, your solution, your output is going to depend on your constant, what you're multiplying by, and by your input variable or your independent variable, the thing that can change. How many hours did they work? Okay. Now, let's go ahead and look at this example. And I've actually got it written down here, right? A factory produces 5 cars per hour. How many cars would the factory produce in 8 hours? So we're doing the same thing. Let's use our formula y equals kx. Now, let me move that down just a little bit. Y equals kx. There we go. Now, what is y? What is k? What is x? Let's identify these in this little story problem that we have going on. So, if it produces 5 cars per hour, it always produces 5 cars per hour. There was no qualifications given there. It didn't say, well, if this happens, then it produces. No, it just says it produces 5 cars per hour. This is our constant. 5 cars per hour is our constant. Now, what is the output? How many cars? That is our output. That's what we don't know, because look, here is our input. We're working for 8 hours. So this is the input. Okay. So 5 cars, that's your constant. How many cars? That's your output. Okay. That's the answer to the question, in other words. And then our 8 hours is our input. That's how many hours we're going to work in order to see how many total cars that we have. I hope that makes sense. This kind of makes sense and it kind of doesn't as you're learning it. But as soon as you kind of put it together, then it all flows and it all makes sense. Probably the biggest question that I get from students is, Mr. Steve, how do I know which one's the Y and which one's the X? Okay. Well, the Y is always going to be your output, or what is going to be your answer. Like it's what the problem is going to give. It's like the how many of the question, right? And the X is always going to be the input, or it's going to be some kind of like this many per hour, or this many per feet, or this many per second, or whatever the story problem is giving you. These are almost always story problems, by the way, okay? These are useful in science class and math class and all kinds of different things that you're going to see. These are like real life type problems. Business, I mean, grocery stores, car manufacturers, t-shirt factories, they all use these in order to tell them, okay, how many will I get if I do this? Okay. These are like conditional things to tell them, well, how many do I need to try to sell, or how many do I need to list on my website or whatever, because it's going to be, if they know how many they're going to produce, right? Then they also know how many hours they're going to work. Then they can tell how many they're going to get after they work that many hours. Okay. So hopefully that makes sense. Now, sometimes we need to find the missing K, the missing constant. What is the missing K? Well, sometimes they don't tell you what the constant is. They don't tell you how many they're producing, right? Here's what they say. They say something like this. Look at this example. How many cars does the factory produce if they make 40 cars in 8 hours? So here, this is the Y and this is the X. And this over here is the K. The K is the we don't know this time. So how do you solve this? Well, you solve it like you would the other one. Remember our formula, right? Y equals kx. Well, you just plug into that formula. So we don't know the K. We do know the Y and we do know the X. So if we put 40 equals K times 8, then we just solve this like we would solve any algebra problem. This is like, you could actually write this the other way too. You could write it 8K if you want to. It doesn't matter, right? You can do that with multiplication. They're commutative, so you can switch those around, okay? So what we want to do is we want to get the K by itself. How do you do that? You divide both sides by 8. That's going to cancel that, and we're going to get this 40 divided by 8 equals k. What is 40 divided by 8? Well, it's 5 equals k. So now we know that our constant is 5. So whatever one you're missing, if you're missing the y, you can solve. If you're missing the k, you can solve it. If you're missing the x, you can solve it. It doesn't matter which one you're missing, you can always solve it if you have 2, okay? So if you have 2, you can always find the third one. Well, what happens if we don't know the x, but we do know the k? Well, we just plug it in and solve it again. So that one would look like this. So if we know the k and the y, so our y is, 40, there we go, and our k is 5, and we don't know the x, right? Well, we just do this, divide both sides by 5, and we get 8 equals x. So there's your x. Okay, so you can find your k, you can find your x, you can find your y based on the original formula. What's the original formula? Make sure that you write this down somewhere. Y equals kx. Now, here's the tricky part. It's not always going to be x and y and k. Sometimes it looks something like this. The circumference of a circle equals what? Pi times d. This is a direct variation problem, okay? Maybe you thought, well, this is just a formula for solving for circumference. You're right, it is. We've done this before, we've used this, but I want you to see what this is. Look, y is our c, that's our output, that's our answer. Our constant is going to be pi, okay? Now, you say, well, pi, what do you mean that's a constant? Pi always equals what? 3.14. That is a constant. That doesn't change, okay? So that part of this formula never changes. And then this x would be our diameter. Why? Because the diameter of the circle changes. Okay, we have one circle with the diameter equals 5, and then one circle with the diameter equals 8, right? You can have different size circles. It can be bigger circle, smaller circle. So the diameter of the circle is always changing, but what never changes is pi, right? So we can multiply pi times the diameter, and that will give us the circumference. This is a direct variation problem. All right, a couple more things here in this lesson, and then what I'm going to do is I'm going to stop this lesson, and then we're going to finish it in the next video. So we'll do all the work, basically, practicing and do some story problems and things in the next lesson. This lesson is more just laying the groundwork, foundation, teaching the concepts of direct variation. All right, so look here, direct variation problems can be graphed. Why? Because of the x and the y, right? We graph x and y all the time, okay? We've just started doing that, so you have an x variable, a y variable. You can put it on the graph, right? We have an x line and a y line. We can do this. Now, take a look at this. These graphs will always pass through origin. Now, let's talk about why. Because anytime you multiply by 0, your output will also be 0. In other words, it has to zero itself out. It's always going to pass through origin. Okay, now, because it does that, the y-intercept will always be 0. Okay, let me show you what that looks like. So if you have a graph and you have a line and it's passing through 0, okay, so here's 0, 0, right? Here's what I mean. This is always going to be the y-intercept. The y-intercept is where it crosses this y line, okay? So if you have it always passing through 0, then it will always cross the y line at 0. It has to. So in graphing, what is the y-intercept? The y-intercept, when we graph, remember, it's the b. So our y-intercept, our b, is always going to equal 0 in these problems. Now, we'll cover this a little bit more in the next lesson, but just watch this. Y equals mx plus b. Now, I just said that b is always going to equal 0. So if b equals 0, check this out. Y equals mx plus 0. You don't even need to write this, do you? Because it's plus 0, and it's always plus 0 because b is always going to equal 0. So check this out. Let's just get rid of that, okay? And again, I said, watch what I'm doing here. Y equals mx. Let's go back up real quick to our original formula. Y equals kx. Okay, now we have, when we're using the slope-intercept, we have y equals mx. Check out what m always equals. Check out what your slope always equals. M equals k, right? Check this out. Y equals kx. It's the same thing. M and k are the same thing. So in direct variation, slope is your constant. Your constant is your slope. So again, next lesson, I'm going to take this and I'm going to show it to you, and we're going to put it on the graph. We're going to work through some of these, but you need to understand these. So if you missed anything, make sure to go ahead, slide it back there, watch it again, make sure that you get all of this, connect all of this in your mind, because in the next lesson, we're really going to start graphing this. We're going to start working some word problems, and we're going to try to put this into practice, what we just learned in this lesson. Okay? That's all I got for you. We'll see you later. Have a good one. Bye-bye.